Okay, so today we're going to talk about the periodic table. Um, this is probably one of the most important lessons you're going to learn um, in chemistry because I think right now you kind of just look at it as a table, but there's no context to it. I'm hoping to give you some of that context because it's super important. You need this to do chemistry. So, pretty much any science, you're going to need to at least understand it. All right, so I'm gonna go over the basic elements of it. I'm gonna pull up the official IUPAC periodic table, and we're gonna talk about different things. Um, and you can either print a periodic table for the video, follow along, and I'm kind of just going to quickly go over some important aspects of it. All right. Anyway, so first thing is keyword elements. So an element is a pure substance. If you remember what that is from Unit 1. Okay, so it's a pure substance made up of only one type of atom. And I'm going to just make it specific. Like, it has to be a specific atom. That's what makes it an element. The other thing we're going to go over is atomic number. So the atomic number is the number of protons in an element. The number of protons in an element. So if you change this, you change the element. So you change which element you're referring to. And no, it's not that simple. But in my class, if you change the number of protons, you are literally changing what element you're referring to. You are stupid pen. Okay. So the periodic table. I'm like throwing all these buzzwords at you, but the periodic table is organized by increasing atomic number. So elements organized by increasing atomic number. And I'm going to go over like two little spots on there that might confuse you. Well, actually, there's a few, but we don't really talk about those anyways in this class, so I'm going to reference them a few times, but anyways. So then we have two more definitions real quick, and I'm going to label some important groups, and then we're going to go in and talk about how it works. So we have the period. So the period is the horizontal row. So it's a horizontal row. There are 7 of them with an island at the bottom. All right, your groups. So your groups are vertical columns. So elements and groups all have similar properties. That's why they're grouped together. I mean, it's common sense, but not really if you're not really explaining. Just looks like a bunch of stuff on a piece of paper. So elements in groups all have similar properties. Okay, so we're going to go over some groups, and then I am going to show you a periodic table, the IUPAC one, and then I'm going to kind of show you how to read it. So write these groups down, and then when I go over the periodic table, we're going to talk about it. So we have group 1. Don't worry, we're going to label these. These are like the important ones. So group 1 is your alkali metals. So these are things like lithium, sodium, potassium. These are highly reactive with water, and they form basic solutions. And this, has to do with the electron configuration, but you guys don't know anything about that yet. So the alkali metals, highly reactive with water. Like if you take pure sodium or pure potassium, pure lithium, and you drop it in just water, it'll catch fire. And sometimes it'll explode. Like it's definitely something I'm not doing in the class. Super, super dangerous. All right, but there's plenty of videos. I'll show you one. It's super cool. It's really reactive. So okay. I'm gonna put a little bit of space in here. I'll go right here. Actually, whatever. So group 2 is alkaline earth metals. Let me write that. So common thread among them is that they're silvery soft metals. So you have things like magnesium and calcium. So silvery soft metals. All right, for group 7, we have halogens. I know you guys have probably heard of actually I don't know. Anyways, but halogens are used in a multitude of things. They're highly poisonous and they're highly reactive. So, and this also has to do with their electron configuration and their electronegativity. So, halogens are poisonous and highly reactive. They're used in things like a lot of insecticides use. Like I know one that's used for the USDA when they're doing testing for certain insects. They use methyl bromide. Super 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 toxic. But they're also used in a multitude of other things. Like if you didn't know, I think it's Splenda. That's what it was. Splenda was actually developed as a pesticide at first, but it didn't have the desired effect, and it was determined that it was sweet. It's supposedly safe to eat. I don't eat it, but it has 3 chlorine atoms attached to the carbon structure. I can show you guys that later, but I'm not going to really go over it now. It's just kind of interesting gee whiz info. So noble gases. This would be our last super important group we're going to talk about. So these are, a lot like my jokes. They don't get reactions out of anything. Um, so another, common thread about, noble gases is they're colorless and odorless, but like the main thing is they're really, really unreactive. Like, I think there's like one or two of them where you can pump enough energy into it and ionize it and react it, but I don't really recall what it is. I think it's like xenon or something like that. But anyways, so we're just gonna go with colorless, odorless, and unreactive. Okay, so if you need to copy any of these, take a second. I'm gonna and pause the video. I'm gonna put this right here. So after this, I'm gonna pull up the periodic table and we're gonna go over that. If I remember where I downloaded it, because of course I wouldn't have it open. It's in here, and there we go. Open. All right. So let's fit. So, anyways, I'm not gonna write on this. We're gonna do that in class. I want to make sure that you guys really write everything down. But I'm gonna just kind of go over. So, let me see if I can pull up. No, we're fine. So, anyways, just follow the cursor. Your periods go this way. They go left to right. All of them. So you have 1, 2, 3, 4, 5, 6, 7. And this is your little island at the bottom. We're not going to talk too much about it, but they fit in right here. These are where you have your f orbitals. But this would be your lanthanides and your actinides. They're special types of metals. I've heard of a few of them, but I used to weld, and when I used to TIG weld, I still use them, but the tungsten, the tungsten tips for the welding torch actually use lanthanum in them, so they lanthanate them. It gives it like special properties for additional heat absorption because it gets really hot. But other than that, like there's specific properties, and some of these like exist in such small quantities on Earth. It's like they don't really have much of a practical purpose, but some of them do exist in decent enough quantities, so they are used. But we're not really going to talk about the island too much, just that it is your f orbitals. We're going to talk about how to do the electron configuration for it, but I'm not sure what all I'm going to quiz you on in regards to that, because my college professor didn't even do that. Now, if you're taking AP Chem, it's a different story. Anyways, so you have period 1, period 2, period 3, and so on, all the way to 7. And this would be the lanthanides would be in period 6, and your actinides would be in period 7. They're not 8 and 9, they're right there. It's just, if we put that in there, this thing is going to take up like 3 sheets landscape. It's too much. So, anyways, then we're going to talk about groups go down, vertical columns. So you have group 1, this is your alkali metals. You have lithium. Hydrogen is not a metal. It's just there because of the electron configuration it has. It's the first element, so that's why it's there. But it's definitely not a metal. Anyway, so you have group 1, your alkali metals, so just kind of cover up the hydrogen. Pretend it's not there for that, but it is in group 1. Group 2 is your alkaline earth metals. So you have things like beryllium, magnesium, calcium, strontium, which used to be used for, I know they use it for certain medical stuff, and then you have barium and radium. So then I'm going to just briefly talk about this, 'cause we're going to go into depth about it later, but these are your transition metals. These are things like iron, copper, zinc, chromium, manganese, cobalt. These are interesting because they fill out your d orbitals, which means absolutely nothing to you right now. But they can have different numbers in terms of their charge, and that's why they're transition metals. We're going to talk about that more in depth, but this is super important. We just don't know anything yet. Right here, we have our metalloids. I'm gonna put a list out. But this thing's really hard for me to read, so I don't remember. Boron, silicone. Yeah, it's 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. I think it's those six. 1, 2, 3, 4, 5, 6. But anyways, it follows a little ladder. I have it highlighted on my periodic table that I've provided for you. That's annotated, but we're gonna go over that in class. Um, they're metalloids because they have specific properties of metals and nonmetals. So like silicone is a metalloid. That's why it's used for making solar panels, computer chips, because it has excellent thermal properties in that it can absorb a lot of heat, but it can also conduct electricity. It's super weird. So, because your computer chips actually get super hot. That's why if you're ever sitting with like a laptop and you don't have like, you're just sitting at the, I don't know, like on your couch or whatever. If you're doing something really resource intensive, it's actually going to, heat up a lot because it's got to process a lot of information. So silicone's used to kind of damper that a little bit. All right, and then I'm gonna skip over. We have nonmetals in the P block here, and then now we're in group 7. So group 7 is your halogens. You have fluorine, chlorine, bromine, iodine. Those are like your main halogens you're gonna hear about. And then all of them are extremely toxic for us, but they are used in certain instances. Like you do have trace amounts of some of these in your body, and they're important for biochemical purposes. Like you'll have chlorine in your stomach because it makes hydrochloric acid. Um, all right, and then the last group is our noble gases. These are the ones that are super unreactive. Helium, neon, argon, krypton, xenon. All of these are, I'm not going all over all of them, but like, these are super, super important. So if you've ever seen like neon signs, they take neon gas and they pump electricity through it. And then that's what illuminates it because of, what we were talking about before with, electrons rising and falling from energy levels. That emission of light comes from the energy being pumped into them. Um, But anyways, so your noble gases are incredibly important for actually welding. Helium and argon are used a lot. Helium not as much anymore because it heats up the weld too much, but in terms of TIG welding, it is 100% or like 98 or 99% argon in the tank. You can't really guarantee 100, but it is super important, and it's also, some of these are in the atmosphere too. Um, So that's pretty much it in terms of what we're going to talk about in the periodic table. I think I already covered what on the periodic table in a previous lesson, the elements, but in case you were curious, there is a key on here. So you have your atomic number, symbol, name. So atomic number, symbol, name, and then you have your atomic mass on the bottom. And that's pretty much it. If you have any questions, please reach out to me, and I'll see you in the next video if I can close this.